Hello students, welcome to Marine Engineering Tutorials. I am Atul Kumar Gupta and back with a new tutorial. Presently we are studying marine auxiliary systems and deck machinery. Today we have 14th lecture and the topic is basic concepts of evaporators and distillers, commonly known as freshwater generators. In this tutorial, we will first learn about the uses of freshwater on board ships. Then we will discuss about the purpose of installing freshwater generator on board ships. Next we will learn about the methods for evaporation of seawater and the sources of heat utilized. Then we will learn about the effect of seawater salts during evaporation and their treatment. Next, we will learn about the operation of single effect evaporator. Then we will learn about flash evaporation. Lastly, we will discuss about the operation of multi-effect flash evaporator. Let us discuss these through the following slides. Uses of freshwater on board. Freshwater on board ships is a scarce but essential commodity and used for the following purposes. Domestic uses. Freshwater is used on ships for following domestic purposes. Freshwater is used for drinking and cooking food. Freshwater is used for taking shower, washing clothes, mopping decks, or washing them with high pressure cleaning machines. On passenger ships, freshwater is used for swimming, splash pool, and water based activities. Technical uses. Freshwater is used on ships for following technical purposes. Freshwater is used as boiler feed and make of water. Freshwater is used as jacket cooling water to remove the heat from diesel engine and compressor cylinders. In addition, use of low temperature or central freshwater cooling system makes the seawater system short and helps in reduction of corrosion due to seawater. Freshwater is used in purifiers as operating water for opening and closing of the bowl and making water seal. Freshwater is used for flushing oil content monitor of oily water separator in engine room and oil discharge monitoring and control system on oil tankers. Freshwater is used as sealing water in liquid ring air pump for creating vacuum. Freshwater is used for maintenance of machinery such as washing turbochargers, compressor and turbine sides during the service, impeller of inert gas fan after stopping, water washing of boiler tubes, chemical cleaning of freshwater generator or scavenge cooler, rinsing cooler tubes or plates, etc. Purpose of installing evaporator or freshwater generator on board ships. As discussed above, freshwater is used on ships for various uses. Freshwater generator is equipped on ships due to the following reasons: reduction of water storage tank capacity. To meet freshwater requirement, ships are equipped with freshwater storage tanks. In the absence of freshwater generator, ship will require large capacity tanks for storage of freshwater, resulting in reduction of cargo capacity. Ships equipped with freshwater generator require smaller capacity tanks for storage of freshwater, especially on cargo ships. Distilled water for boiler and cooling systems. Distilled water is required for boiler and cooling water system, which is not easily available in most of the ports. Thus, freshwater generator becomes a necessity on the ships. Improves plant efficiency by waste heat recovery. On motor ships, fresh water is generated by utilizing the waste heat of propulsion engine given up in jacket cooling water. Seawater is the obvious choice for its distillation and protection of water on board ships. Acts as jacket water cooler for propulsion engine. As freshwater generator utilizes the waste heat of diesel engine jacket cooling water, it actually acts as a cooler for jacket water. Can generate water in harbor during emergency. If freshwater generator is equipped with steam heating system, it can be used in emergency to generate water when there is long waiting at the harbor and fresh water or distilled water cannot be received from shore. Methods used for evaporation of seawater and sources of heat utilized. Methods of evaporation. Two methods have been used for evaporation of seawater as described below. Evaporation under pressure. This method was used in earlier ships where seawater was evaporated under pressure of 1.34 to 1.48 bar at temperature of 126 degrees centigrade, which caused more scale formation, but the water was free from bacteria. Evaporation under vacuum. This method is prevalent nowadays and facilitates boiling of seawater at temperature between 40 to 50 degrees centigrade and reduces the scale formation, improves heat transfer due to high temperature difference, permits the use of waste heat from diesel engine cooling water, but requires disinfection when used for drinking purpose. Heat sources used. Following two heat sources are used for evaporation of seawater. Engine cooling water. In order to make the diesel plant further efficient, the waste heat of the diesel engine cooling water is used to generate fresh water. Steam. Steam was the obvious choice for evaporation of seawater on earlier ships propelled by steam. Steamships mostly used waste steam as blade or leak of steam for production of water. Some freshwater generators on diesel ships are equipped with arrangement of steam heating which can be used while the ship is in port. Being expensive, this method is used in extreme emergency. Effect of seawater salts during evaporation and their treatment. During the evaporation of seawater, effect of salts on the evaporator tubes and their treatment are discussed below. Increase of salt concentration. When seawater is evaporated, salts contained by the evaporated water are left behind, which increases the concentration of remaining water. To reduce the concentration of salt in remaining water, which is called brine, feed water supply is almost 3 to 4 times as that of the desired output. Scale deposition. High concentration of salts tend to deposit scale on the evaporator surface, which reduces the heat transfer greatly, resulting in lowering the output of freshwater generator. Deposition of scale is more pronounced when condensation temperature or corresponding shell temperature is high. In-service chemical treatment. To prevent scale formation during the operation of freshwater generator, chemical is continuously dosed in the feed water. Acid cleaning of evaporator. When the ship arrives in the port, acid cleaning of evaporator is performed to remove any scale formation and subsequently it is neutralized to remove any remaining acid which can cause corrosion. Single effect evaporator. Single effect vertical evaporators were commonly used on earlier ships until flash type evaporators were developed. It consisted of heating coils located at the bottom of evaporator shell. Seawater was supplied to the evaporator shell by the general service pump which kept the heating coils submerged. Excess feed water supplied for the removal of salt flowing over the weir was collected in brine tank. Brine was continuously discharged overboard through the brine pump. Side glasses were provided to monitor the brine level in the evaporator shell. Steam was supplied directly from the boiler to the solid drawn copper tubes through inlet header. Condensate was passed through steam trap which ensured that latent heat of steam was recovered before the condensate was returned to the cascade tank. Pressure of the vapors in the evaporator shell was monitored by the pressure gauge. Water was evaporated at pressure between 1.34 to 1.48 bar and shell was protected against high pressure by a safety valve. Evaporated vapors were passed to the condenser through baffle to prevent carryover of seawater droplets along with them, which helped in keeping the salinity of the evaporated water within limits below 5 parts per million. A reducing orifice was fitted in the steam inlet pipe, which reduced the steam supply if the heating coil was ruptured. After stopping the evaporator, seawater and brine left in the shell were drained to the bilges. Flash evaporation. Principle of flash evaporation. Flash evaporation works on the principle that boiling point of a liquid can be reduced by lowering its pressure. We know that water boils at temperature of 100 degrees centigrade at atmospheric pressure. But if the pressure is reduced to 0.06 bar, water boils at 40 degree centigrade. Mechanism of flash evaporation. When heated seawater enters into the flash chamber, part of the seawater is immediately evaporated due to low saturation temperature corresponding to the low pressure in the flash chamber. Advantage of flash evaporation. Flash evaporation helps in utilization of waste heat of engine cooling water having temperature below 100 degree centigrade for boiling seawater, which improves plant performance. Evaporated seawater contains negligible salts, which is absolutely necessary for use as boiler feed water or engine cooling water to prevent corrosion and scale or sludge formation in these systems. Limitation of flash evaporation. Boiling the water at low temperature is unable to kill pathogens, which include viruses, bacteria, fungi, and parasites responsible for causing various diseases if untreated water is consumed. For other domestic purposes, evaporated seawater needs to be rehardened. For drinking purpose, evaporated seawater needs to be sterilized or disinfected either by chlorination or passing it through ultraviolet rays. Multi-effect flash evaporator. The sketch shows a two-stage flash evaporator used on steamships. The series operation of flash chambers utilized here reduces the heat input as seawater temperature is gradually increased while passing through the condensers, utilizing the waste heat of condensation, and plant output is increased by allowing more surface area for evaporation in flash chambers maintained at different pressures. It consists of two flash chambers. Air resistor E maintains vacuum in flash chamber. Air extraction line consists of a non-return valve NRV to prevent backflow of air. An orifice is used to maintain pressure difference between the two flash chambers. Seawater is supplied by service pump SP, part of which is supplied to the air rejector for maintaining vacuum in flash chambers. Flow of seawater to the flash chamber is controlled by flow control valve FCV, which is operated by float switches in first chamber, thus maintaining the water level. Seawater first condenses the evaporated vapors in both flash chambers where its temperature rises and then heated by steam in the heat exchanger to 80 degrees centigrade before entering the flash chamber. Part of the heated and pressurized seawater on entry into the flash chamber evaporates due to low saturation temperature corresponding to low pressure in the chamber. Unevaporated water is passed to second chamber through the orifice which maintains pressure difference. Water is further evaporated in second chamber maintained at lower pressure than first chamber. Unevaporated water is discharged overboard by the brine pump BP. Part of this water is returned to the inlet of service pump SP through temperature control valve TCV to maintain inlet temperature at 30 degree centigrade. Vapors evaporated in flash chambers are passed through devistors D, preventing the carryover of water droplets with them before entering the condensers C. Distillate from each chamber is drawn by distillate pump DP. A salinometer SM monitors the salinity of distillate through the salinity cell SC equipped in the distillate pump inlet. A solenoid operated dump valve DV at the delivery of distillate pump returns the water to brine pump BP suction if the salinity exceeds 5 ppm and prevents contamination of water in the storage tanks. This completes the study of basic concepts about freshwater generator. This book is written by me and covers all the topics as per syllabus specified by Indian Maritime University. It clarifies the concepts with simple illustrations. The book also provides answers to all the questions which have appeared in the examination conducted by Indian Maritime University. The book can help the students in preparing for the exam and also to work on ships, auxiliary systems and deck machinery safely. Hope that you have liked the lecture. You can write your feedback in the comment box. If you have liked the tutorial, you may share it with your friends. You must subscribe to the channel for getting notification about the new tutorials. I will be back with a new lecture shortly. Thanks for watching till the end.